Okay, today we are going to look at solving quadratics. There are several different methods for solving quadratics. So today we are going to focus on just the square root method. And the square root method you are going to use when you have this format in your equation. So ax squared plus c. So if you think of what a quadratic looks like, we usually have the ax squared plus bx plus c. So we're missing that middle bx term right here. So when we have ones like that where it's just the x squared part and a number, we can use the square root method really easily, and it's a pretty quick method to use. But before we look at how to do that, just a quick reminder about when you are using square roots. If I solve this equation, x squared equals 64, and I'm trying to solve for x, the way to undo a square would be to do the square root. So the square and the square root cancel, and I would just get back x equals the square root of 64. Well, the square root of 64, probably right away we think is 8, because 8 squared equals 64, but so does negative 8, because negative 8 times negative 8 turns to a positive 64. So whenever you are taking a square root, there's really going to be two answers, the positive and the negative. So always remember that you will have two answers when doing that. So let's look at some equations. So if I have this one right here, x squared equals 49. Again, we take the square root because that cancels with the square. And the square root of 49 would be 7, but also negative 7. So don't forget the positive and the negative. So when they are perfect squares like this, the problems go really quick. But sometimes you're going to get some that aren't perfect squares. So like if I try to take the square root of 45, that's not a perfect square. So what we like to do is break this square root down. So you want to think of a perfect square that does go into 45. So our perfect squares would be 4, 9, 16, 25. And I know that 9 is a perfect square and it goes into 45. I like to do the little factor trees too if you go off to the side. I know that 9 times 5 is 45. So the square root of 9 times the square root of 5 will be the square root of 45. But the reason we like to do that is because since 9 is a perfect square, I can actually take that square root and get back 3. But then 5 is not a perfect square, so we're just going to keep it in that square root. So both of these parts are going to become our answer. We'll have 3 times the square root of 5, but then also the negative version, negative 3 and the square root of 5. So that would be your answer. So we do need to break down those square roots all the way and simplify them whenever it's not a perfect square. Also, another thing is when we take square roots, we can't take square roots of negatives. They create imaginary numbers. We're not going to focus too much on imaginary numbers right now, but in math, if we take the square root of a -1, since square roots of negatives aren't allowed, we like to just say that it is this little imaginary I. So it's kind of a little bit of a cheat, but what we're going to do is we're just going to still say the square root of 16 is 4, but because it has that negative on it, we're going to throw the little I on there. And then we'd also do negative 4i. So that would be your answer. So you won't see too many of those yet. We're not going to focus too much on imaginary numbers, but whenever you get those negatives, pretty much all you're going to do is throw the little i's on them instead of the negative. Okay, let's look at this one. We're solving for x squared, or solving for x, so we have a extra step here that we haven't seen yet. We want to get x alone, so before I can take the square root, I need to get rid of this plus 8 by subtracting 8. So those cancel, and I get x squared alone, and then -4 subtract 8 would be -12, and now I can take the square root. But I do have that negative there, so that means I'm going to put a little I on it. And then 12 is not a perfect square, so let's do our little factor tree really quick. Well, let's put the negative on there. So I know that that negative is going to put an I on there, but then for the 12, a perfect square that does go into 12 would be 4. And I know 4 times 3 is 12. So that's going to be your little factor tree. Well, the square root of 4 is 2, so that 2 is going to come out of the square root. We're going to keep the square root of 3, and then that I is going to be on there to take place of that negative inside. So we're going to have a positive and a negative version. And if you get sick of writing the answer twice, you can do this little plus or minus sign, which means that you're doing the positive and the negative version. So I could do plus or minus 2 square root 3 I. And some people will put the I in between the 2 and the square root. Some people put at the end. It doesn't really matter as long as you have it on there, but that would be your answer. Okay, so let's look at a couple more. So let's solve these quadratics using square roots. And again, notice that we have the x squared term and a number term, but there's no x term in the middle. So that's why we like the square root method. So to get x alone, first I'm going to have to get rid of this minus 25 by adding it over to the other side. So I get x squared, those cancel, and then equals 25. Now I can take the square root. Lucky for us, 25 is a perfect square. So the square root of 25 is 5 and negative 5. So don't forget that negative 5. It's really easy to do when you're going quick. Okay, on this one, again, we're trying to get x alone. So before I can take the square root, I need to get rid of this minus 6 by adding 6. We always do the opposite operation. So 6's cancel. 10 plus 6 is 16. Now we can take that square root. So the square and the square root cancel, and we know the square root of 16 is 4, but also negative 4. So again, you can just do that little plus or minus sign in the front if you want, and that will mean the same thing. Okay, let's look at some more. I'm going to make these a little bit more complicated as we go. So trying to get x alone, I say I have a times by 6 and I have a minus 54. For your order of operations, we're going to get rid of this minus 54 first by adding 54 to the other side. So I still have the 6x squared equals 54, but then I still can't do the square root until the 6 is gone. So to get rid of a times by 6, we need to divide by 6 first. So I get x squared is equal to 54 divided by 6, which is 9. And now that I have the x squared alone, I can do the square root. And the square root of 9 is going to be 3 and negative 3. And so that would be your answer. Okay, let's look at another one. Let's add this 12 over first. Those cancel. We've kind of already done 12 on the other page. When I take the square root of 12, it's not a perfect square, so we're going to do our little factor tree here. We want a perfect square that does go into 12. So 2 and 6 make 12, but 2 and 6 aren't perfect squares. So we want to do 4, since 4 is a perfect square, times 3. And again, the reason we do that is because 4 is a perfect square, so I can reduce it to be just 2. And then since 3, you can't do anything with it, doesn't go into the square root, we're just going to keep the square root of 3, keep the 2. And then I'm just going to put the little plus or minus on here. So we have the positive and the negative version of 2 square root 3. And that would be your answer. Okay, so on this one, notice that the square is on the outside of these parentheses. It's not on the x. So that does change our order of operations a little bit. Normally we would get rid of this plus 2, like how we did the minus 54 and the minus 12. But because it's inside the parentheses being squared, we actually need to get rid of the square first. So notice whenever things are stuck inside those parentheses, you kind of need to work from the outside in. So we're going to get rid of this square by square rooting first this time on each side, so that this square root cancels with that square, and that means that x plus 2 can come out of the parentheses. But the square root of 4 isn't just 2. Remember, it's 2 and negative 2. So we kind of have two equations now. I need to solve for when x plus 2 equals positive 2 and also when it equals negative 2. So that kind of makes it a little bit tricky, because we can't just forget about the negative 2 answer here. So we're splitting our equation into two parts where we're checking both the positive and the negative outcome. So once we do that though, we just solve normally. So like on this one, I would, to solve for x, get rid of the plus 2 by subtracting 2. That cancels, and then 2 minus 2 is 0. So the answer for that one is 0. But then I need to also do it over here again, so minus 2 a second time. And then negative 2 subtract 2 is negative 4. So we have two answers on this one, 0 and negative 4. So the order of steps is a little bit different when you have that square on the outside of those parentheses like that. And then if it happens like this, you do need to still take the positive and the negative and do your equation 2 times, checking both results. Okay, let's try one more. So here, we just have the square just on the x, so we're gonna solve normally. We need to get rid of that 2 and that minus 5. We're gonna get rid of the minus 5 first for our order of operations, so we're gonna add 5 here. So we have the 2x squared left, and then 43 plus 5 is 48. But then now to get rid of the 2, we're gonna divide by 2. So we have x squared equals 48 divided by 2, which is 24. And then now we can get rid of the square by square rooting. 24 is not a perfect square, so we want to think of a perfect square that goes into it. So again, you do need to make sure it's a perfect square that is inside of it. So like 2 and 12 make 24, but 2 and 12 aren't perfect squares, so it's not going to help our situation at all. So I want to think of what is a perfect square that does go into it. So your perfect squares are 4, 9, 16, 25. And I know that 4 goes into 24, and it is a perfect square. So 4 times 6 is 24. And then we can reduce that square root of 4 into a 2. But then 6 is not a perfect square, and you can't reduce it anymore, so you're just going to keep it. So our answer is going to be x equals 2 square roots of 6 and negative 2 square roots of 6. I'm just going to do the little plus or minus in the front. And that would be your answer. So just be careful on those ones where you need to reduce those square roots. Do your little factor tree and just make sure one of the factors is a perfect square, or it doesn't work. So, okay, so that is it for today's lesson. Your assignment is just on Math Excel 3.1, so go ahead and hop on and get started on that. And as always, if you guys have any questions, feel free to shoot me an email. Hope you guys are doing well and you are safe and healthy. See you later.